Okay, hello everyone. My name is Cindy, and my topic is diurnal sea surface temperature warming along the Kuroshio of Taiwan under easterly wind conditions. And first, you may think, what is diurnal sea surface warming? So you can see in this figure, in the upper ocean, heat content will change steadily due to the heat source from the sunlight. So you can see the warm water will accumulate here, and it creates a thin warm layer extending several meters beneath the sea surface. However, we won't see the warm layer during the night because we don't have the heat source. And you can see that these two warm layers, the thickness and its mean temperature is different because it will depend on wind, current, or subsurface ocean mixing. So the most important is that this warming event, it only happens during the daytime and it won't happen at the night. Next, we have the unique environment east of Taiwan. And it's under easterly wind conditions, which is affected by the high pressure system in the Pacific Ocean. So when the easterly wind encounters the mountain and the terrain rising, it will separate to northward blowing winds and southward blowing winds. And then we have the Kuroshio current here. So the importance of this study is that sea surface temperature plays a key role in global air-sea interactions as it affects the exchange of heat between ocean and atmosphere. One important factor affecting sea surface temperature is the heat source from the sunlight. By understanding the sea surface temperature variation well, it can help us to predict the typhoon and deadly weather. And next, we have the unique environment east of Taiwan. So the sea surface temperature would be very in space along the coastline. And the result may be different from the warming happens in the open sea. So it will be interesting to explore whether the easterly wind and strong western boundary current could affect these warming events. For our data methods, we use the drifting metal ocean buoy during this cruise. And it starts from here along the Kuroshio to end here. The buoy was equipped with some sensors like to measure wind speed, to measure solar radiation, and ADCP to measure currents, and 52 temperature sensors. We also use the weather data from Hualien Station to support our study. We use satellite data as well, like sea surface temperature, wind data, or current data. In addition, we use the sea surface temperature satellite data from Japan, and it's to linearly interpolated to this buoy drifting path, and for comparison. And the result is like this. The distance is along this path, and the whole data is linearly interpolated. So the key points of this study is that the first, the observation shows inhomogeneous diurnal sea surface temperature warming along the coast east of Taiwan. And the second is that inhomogeneous diurnal sea surface temperature warming is due to the easterly wind and the strong Kuroshio current. First of all, we can see these two figures is during daytime and nighttime. And in the color of the background is sea surface temperature. The blue is the lowest and the red is the highest. And this black vector is the wind speed with this length of 5 meters per second. So what can we see in this figure is that where the wind were separated. And it is called wind speed point, which means is no wind is moving north or south. It's like this direction. And also you can see near this wind speed point, the vector is shorter than in other regions. So we can know that near this point, the wind is lower. And according to our analysis, it's about 2 meters per second. So we define if the wind is smaller than 2 meters per second, then it's the low wind region. Okay, so next we can see this region, the color is really red, but in other places it's not. So we know there is inhomogeneous sea surface warming, and it is near the wind split point and along the coastline. However, we won't see this. We don't see the warming happens during the night time, so we can know this warming event is diurnal sea surface warming. So far, we can know the inhomogeneous diurnal sea surface temperature warming. And next, I'll explain how the wind and the current could affect these warming events. We use the data measure from the buoy first. First is the temperature, and the second figure is apparent wind speed, which means it's the speed relative to the current. And you can think that if the current is northward 1 meters per second, and the true wind speed is southward for 1 meters per second, then the apparent wind speed is 0 meters per second. The third figure is a little bit difficult, so what we should know is that it shows us whether the water is stable or not. Blue means it's stable, and red means it's unstable. So we can see two warming events, and we see the second warming event first. You can see where the warming occurs is relative to the low wind region, which is smaller than 2 meters per second, and the seawater is stable. So what can we know is that if the wind is lower, then the upper ocean water will not mix with deeper ocean water. So the energy will keep and accumulate in the upper ocean. Then we can see obviously sea surface warming events. But back to the first warming events, you can see the wind is a little bit stronger, but the water is not that stable. So we cannot see the obviously sea surface warming. While we just use apparent wind speed to prove, then we add true wind speed for comparison. Along the x-axis is the time from September 1st to September 11th. Along the y-axis is the distance along this black line. So at first, what we need to know is that this brown color is the low wind region, which is wind speed smaller than 2 meters per second. And we can see most sea surface temperature warming events is in the north portion of the track, which means it's northern than this wind split point contour line. Also, the low wind region of the apparent wind speed has a similar result, but the true wind speed is not. The low wind region of the true wind speed is in the southern portion of the track. So what can we know is that Kuroshio current could affect this sea surface warming because Kuroshio current is northeastward, so it will bring the warm water northward. Then what we can see is that when the warming happens, it's not right at the wind split point. It's northern than the wind split point. So in conclusion, we can know there is the easterly wind, and when it encounters the terrain rising, it will separate to northward blowing winds and southward blowing winds. Then it will lead to a low wind region. Also, we need to consider the Kuroshio current. So when the apparent wind speed is lower, which is smaller than 2 meters per second, then we can know that seawater stays near surface because surface water cannot mix with deeper water. It means water is stable. So we can see strong inhomogeneous diurnal sea surface warming. However, if the apparent wind speed is stronger, Then you increase the upper ocean water to mix with deeper ocean water. Then it means the water is unstable. So we will see weaker diurnal sea surface warming event, or we won't see the diurnal sea surface warming event. So thank you for your listening.
And I think you did your PowerPoint is better than last time because it's more readable in the text. And speak talk is more, I can say loud and clear and easier to understanding. That's all.
I think you did a lot of improvement on simplify your presentation, because last time is much complicated than this time. So this time is more easier to follow, and I think it's a great improvement.
I think you did a great job than last time, and your talking speed is smooth, and your PPT slides is more understandable and easier to follow. Thank you.